Hello, my name is Alex Thomason. I am doing extra credit from Unit 6.2 and problem number 770 and is worth 5 points. The question asks, on the Richter scale, the magnitude of R of an earthquake of intensity I is R equals ln of I minus ln of I naught all over ln of 10. Where I naught is the minimum intensity used for comparison, and to assume that I naught equals 1. So, part A wants us to find the intensity of the 1906 San Francisco earthquake, where R is 8.3. And given our original equation, since I naught is 1, ln of 1 is 0, so we can exclude that from our equation for this part of the problem. So R equals ln of I over ln of 10. R ln of 10 equals ln of I. So if we raise both sides of the equation by e, then we can see that e to the 8.3 times ln of 10 equals I. So all we have to do is plug that into the calculator, which I already have done, and we get this number. So I equals 1,995,2,6,231.497 when R equals 8.3. Alright. B wants us to find the factor by which the intensity is increased if R is doubled. R equals ln of I minus ln of I naught over ln of 10. And we know ln of I naught equals 0 because I naught equals 1. So we can eliminate from the equation. So R equals ln of I over n of 10. Alright? So we know that 10, or ln of 10 times R equals ln of I. And we know that e to ln of 10 times R equals e to the ln of I. I just raised both sides of the equation by e, and we know this is e to the ln of 10 to the power of R equals I. And so we know that this right here equals 10. So we know 10 to the R equals I. So if we say that R2, let me rewrite that, R2 equals 2 of R1, then 10 to the R1 equals I1, and 10 to the R2 equals I2, right? And from there, we can say that I2 over I1 equals 10 to the R1 or 10 to the 2 times r1 over 10 times r1, which equals 10 to r1 minus r1, which equals 10 to the r1. And this is the factor when r is doubled. And we can see that from part A. Let me look at the calculator. E to the 8.3 times ln of 10 is this number. E to the 16.6, which is twice of 8.3. So e to the 16.6 times ln of 10 is this number. And if we divide these two, it ends up being 10 to the 8.3, which is 10 to the r. So it all fits. Part C wants us to find dr over di. So given our equation, r equals ln of I over ln of 10, r equals 1 over ln of 10 times ln of I, and this is our variable. So dr over di equals 1 over ln of 10 times 1 over I. And so we can say dr over di equals 1 over I ln of 10. And that is our derivative of our equation.